people come to watch the show. Hey, Chris is here. Nice. Welcome, Chris.
Hey guys, can you hear me okay?
Hey, yeah.
Hey.
Hey, I just pinged you. I hope it's okay that I join. I know I kind of vanished for a bit, but figured I'd hop in today. Y'all are, how you doing?
Chris, why would it not be okay that you join?
Yeah,
Come on.
it's always okay, man.
Thank
I'm
you.
very happy to have you here. We were just basically talking about the new thing, what we're into.
The comet?
Well, actually, we were just getting settled on the new layout for the show and everything like that, but cool. It's taking a lot of your advice, actually, with audience and stuff like that. But I was obviously going through a thing that we knew that was going to happen. So even though it was kind of weird, it's very weird that you actually know you're going to get depression and you're like waiting for it. And then you're like, okay, and it's going and then it passes. It's like, yeah, because nothing's changed. Everything's exactly the same in your life, but you were just depressed. You know right then that it's a chemical thing. You know what I mean? Like, it's not.
I agree. Seasonality, with the artistry, with money, with depression, like comes and it goes, and you have to have faith that it will come around.
This was a cycle. This was a situation where I was changing my medication with my doctor because the other one wasn't doing so well. Mm-hmm. So we knew that the change was going to cause this. So, I was ready. Like, it's unlike to be ready for it. You're prepared for your depression, So right. I had an opportunity to talk to people about it, and I wasn't going to be broken up because I knew the feeling I had was temporary. And, you knew it. I mean, everyone knew it. The doctor told you it was going to be that way. So it worked out. But
well, good, excellent.
So I'm obviously feeling better, and my microphone is brand new, and we were just talking about its quality. So how's it going there? How's it sound? Our friend.
It's perfect on
really
on YouTube. Yeah, it's perfect.
I like that.
Everybody can hear everybody, and including you with your brand new microphone. Lucky bugger.
What happened here? Oh my God, no. Who cares? I'm clicking too much on Warframe. Not enough on what I should be doing. Sometimes, that was my go-to escape thing, but then I found it was all about catastrophes, and I was like, I need to link these things together. Because clearly, when I realized that there's an entire generation that we've ignored, and they're just going to be sitting there looking at YouTube videos for the rest of their life. That's going to be TV.
Right.
And
sure. But I think it's interesting what's going on,
Well, tell me more. Tell me more about what you find interesting, Chris.
Well, so few, I don't know. I mean, I feel like it's not made a massive jump forward, but I think the people who are in this community or are thinking about science differently have reached certain thresholds where they're like, okay, there is something going on. Even mainstream cosmology is like it's
slowly changing
really little bit, and you start to think, you're like, okay, are we chipping away at this? Is there a greater shift going on? Has quantum hit its threshold? It sort of has a little bit. But again, it's the same sort of shit. Seasonal, right? I'll see some good things, and then I'll see the World Science Festival, and I'll be like, ugh, this is garbage.
One of my favorite things is somebody said to me in the solar. It goes, the solar wind is made up of positive and negative particles, and they're all traveling away from the sun. So this means that this is not an electric current. Okay, and I'm sitting there going, okay, hear me out. I'm flowing mercury down a hill. Can I make the electricity in this mercury wire go up or down? Does it care about gravity at all? No, it doesn't care. Because electricity is not the movement of the particles themselves, it's the movement of the space between them when they open and close, open and close, open and close, and pass that charge along.
Right.
And that's the electric current. That's why I said there's an electric field. And that, all that, putting that into their mind, I mean, it bothers me greatly, like to a point where it hurts. And this is where something like, for example, Gareth is explaining this right here. And it's on the screen, and basically what he's describing is the like principle, and how charged bodies are supposed to repel. But it's a dynamic situation. If you get two charged bodies like the Earth and the Moon, as Chris would love, well, one of the questions is, why is it sitting there? Why is the Moon sitting there? You know, well, if they're both similarly charged or positively charged or whatever compared to the surroundings, they will build up an area of negative charge between them. And so they will sort of glue themselves together because they become a triplet, which is what our friend Edwin was talking about with when he basically said this is like a neutron held together, two protons held together with an electron. That's a neutron. You know, and you hear stuff like this and you're like, what? Well, not quite like that, but you know, they're stuck to something, but they're basically a joined pair that only exists because of this principle. It's
glued together by possibly an electron with a higher charge than
in between
the ones that are orbiting.
Well, no, it doesn't have to have a higher charge. It would just be in a more compressed area, because it would be, well, remember how we were talking about what would happen if the sun entered into a different, or Saturn entered into the sun's heliosphere, and how it shrunk Saturn's coma? Well, that would be a similar thing to say, that it entered into the nucleus and its coma had to shrink down because of the electrical fields around it. They're cellular structures, after all, and this is basically where they're dynamic.
Right.
So if you could envision, right in between these two things would building up amazing charge, and this is why they cannot touch either, because they will obviously build up charges against each other inside of themselves. This is a very interesting situation, which is why I think some odd situations occur when we're discussing the slingshot effect, anomalies, which are, well, anomalous velocities in flyby anomalies and such like that.
And
this could be some
gravity
of the principles.
Anomaly at the one side of the Earth.
Well, I don't know what's causing that, to be honest, because obviously the Moon moves in the sky. If it was affecting charge on the Earth, that would be something we should know. However, we do know the sun does. So, but the sun is also giving off.
Well, I think that gravity anomaly is that loop area where the Birkeland currents come off of the sheet.
I would like to agree with you, but then again, I don't even know how a tornado works, and I have an idea, but you know. So anyway, Chris, and well, Sean was here, and of course we have James and Rick. So what we're doing, I got a new microphone, as you can probably hear, and we're having a conversation about basically the upcoming, what we're going to do in the show. This is going to be more of a behind the scenes show now, if we can do it correctly, which we'll basically be seeing behind the scenes footage of us making a video. So we're going to have a question come up in the future here, and like in a little bit, we're going to try to answer that, and for about half an hour, and we're going to take some shots, and then of course some of us might even be learning for the first time some of these things, and we've talked about some of the potentials briefly. One of the and of course Rick would like to also talk to you guys more, get more acquainted with letting you know what you're going to be able to be seeing. And I find most of this to be fascinating. Plus, we're talking about the community at large, and also, well, apparently Professor Dave made another terrible video, but I might have to attack that. I would try to avoid it because it hurts.
Oh.
Not attack it, address it.
Address it. Oh, thank you. Thank you. So address. That sounds so nice.
Attack is so aggressive.
I was wondering if there are a different way to approach that cat. You know,
Well,
I realize
I
like
think the wall's already been
purchasing
poisoned.
power, right? I mean, I feel like it's people who it's allowing him to be legitimate is what makes those people kind of more effective than they really are.
Well,
you know, legitimizing or repeating, basically coming into somebody's chat and being like, "This guy, Professor blah blah blah, said this." That legitimizes his voice versus just basically understanding that the guy is a total hack.
Well, I think
and like ignoring the channel and basically.
No, I didn't even bring up the
yeah.
address. I actually, in my last video, which talked about his issues, I went over the most fundamental issue that he had, which is his delusion about science not having anything to do with people and always being empirical. Like, no, it's driven by people. It's all in our minds, literally.
And he brought his main point is that they can't be wrong. It just it's not possible for them to be wrong. And that's a delusion of the highest sort as far as science is concerned.
No matter what your belief is, in many cases, and obviously I try very hard not to have too many. But either way, maybe I'll address those. I mean, I'm like I said, I got a new microphone now. I got everything handed out. We're gonna have to ask questions when we have something that we can't answer. So I could expect that I might have to ask Tess for help with comments and so forth, you know, if there's questions that arise on that. And then in the middle of the week, I should have 15-minute, well, we're going to start with just one at the beginning, a 15-minute video on what we talked about, whatever the question is, which I know, but we're not going to tell you because surprise, spoilers and all that. So also, last but not least, Warframe, because of its post-apocalyptic nature, I'm looking for people who want to discuss it while we play it. It's free to play. If you have a computer that can play it and you want to do it, me and Chris play, and we're trying to basically attract younger minds that are literally playing video games and watching streams all the time. They're the people who could understand if you go, no, you see how the Orokin are like this? Imagine they were just the ancient Egyptians. Okay, what would it look like years later? Oh, like this, like this. Oh, that's why we find things. Yes, and there's so many similarities between the two, even though it's in the future. The setting is anyway. I find, and of course, the psychology of it is very, very entertaining. So on that level, for me anyway. Plus, it's also visually stimulating. So hopefully that could work out. But it might not. But that will be a Twitch thing, nothing that's going on to YouTube. So the Twitch stream is available in the About section, I think. And yeah. So yeah, right there.
So, you know, there was one thing I wanted to address about what Gareth's thing was that you were talking about. And
sure. It's not like we're not getting to know each other again and stuff. So.
Well. But one of the things is that that is coming out is there's a certain amount of spacing, as you said, between the electrons. There's a certain amount of spacing that's occurring within the planets and the sun and this stuff like that. Correct. So it's kind of like there's a ratio, and when things get closer than that ratio, and when things get further away from that ratio, it's kind of like action happens and or things speed up or slow down.
I think it's more dynamic.
Depending on charge.
Well, I'll give you an example that what I mean by dynamic, but it happens very quickly. You might not think of it like that, but feedback is a dynamic situation. It has to do with the distance between the microphones, how fast they're echoing off the walls, and then how fast it can get processed by the audio processor and then fed back through the system again. Now, that takes a certain amount of time. That time will determine the frequency of your feedback because it's happening so many times per second. Now that is an electrical balancing act that has to do with an acoustic variable, but it happens instantly. Like, you know, it just gets louder, but it will find that balance point very quickly. You hear woo, 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 like that. Well, the same thing must be happening in many cases with planets and stars and so forth. Like if the explosion that created the Pleiades was a ring that was moving outwards and blasting through us, it would sort of also have like a rolling density to it, where it would be pulling things in and then letting them roll through it in the whirlpool and then continue on. So, and of course, because it would form tendrils, the right-hand rule would always make those occur, which of course, we're stuck on the side of one, it appears.
Yeah, I was just wanting to add that each of those ratios could be different within inside a bubble, and that how their interactions of those bubbles is so it's not the same for everything. That's kind of basically what I'm going to say. Thank you.
No problem.
What can I just throw a thought? Maybe quantization or octaving.
Ooh,
basically,
yeah, those are
how
very...
like you have note cycles, and then it repeats, but an octave further. Same thing with like maybe these plasma layers. Maybe you do have the double layer for every layer, but each double layer is based on a certain type of resonant distance to the next one. But then it also is quantized a little bit, like the concept, the whole redshift thing that we're talking about, and also in terms of light perturbation in the ether being also quantized in terms of how light reaches us, so to speak, or how light travels, but it doesn't really travel.
Well, and that's the question: does light actually travel? There's a debate. Obviously, I'm in the camp of waveforms, but at the same time, I have to admit that electrical waves don't travel. Electrical waves inside wires don't travel. The electric force doesn't seem to travel. It appears to be instant.
But isn't it like that rope, like where you jar the rope from one end and then it kind of pushes that?
Well, yes, normally
momentum
it would be
through, but basically the rope is not moving. I mean, it's moving.
It's more like gears. That's more or less what it is like. It's like gearing, and that's what. And you're basically moving it back and forth 60 times a second. So you're basically taking a very long chain and you're going and just wiggling it back and forth very quickly. Now the thing is that in that wiggling, it's the same. It looks like a rotation to a graph. So you can plot it like a circle. But anyway, besides all that, we don't take into consideration the speed of light when we do this. No matter how small the cycles, right down to in the computer. Like, why don't we don't take that into consideration at all? We assume that this wire is solid and moving back and forth very quickly, and everything on it is doing the same thing, just wiggling back and forth very quickly. And that's it.
Let me throw something in. Maybe it's naive, but let's consider like when you look at a spoon if you put a spoon in a glass of water and you see it diffract.
That's why I don't take baths.
And so essentially, like a scientist or pop science will say light's slowing down and then speeding up. Ken Wheeler will say light can't do work on itself and re-speed up after it goes through a medium. Literally, it's density of the medium that's causing this diffraction. So we also have gravitation.
There is a density of medium, yes. That gives you the index of refraction between the two substances, yes.
Right. IOR is different for different materials. Like you have treacles, you have waters, you have airs, currents, and so index of refraction is going to change for each of these. Right. The reason it changes is density, right? Whatever density is, like if you want to interpret it as packed, so-called particles, or looser particles, right? Let's just consider this in conjunction with gravitational lensing, the concept of lensing. If people don't know what that is, that's basically light warping around an object in space and being bent. And I'm putting a lot of air quotes here, but just imagine everything about pop is basically air quotes here. But what, Neil? Sorry.
No, I was just agreeing with you 100%.
Yeah. So diffraction, spoon in a glass, gravitational lensing, light curving around like an exoplanet, let's say, or any type of astronomical body. So this density to me seems like this kind of not just well, quantization is one thing, but it's the stepping of density. So what is, what's happening right now? Sorry, I know I'm taking the long way around
No,
here,
that's
but
still fine. It's fine.
but speed of light or distances to planets, saying like the sun is 1 light second away, or the moon, sorry, is 1 light second away. The sun is like 8 minutes away. Are we taking into account these dense layers, this potential diffraction of light, when it comes to measuring light years and light seconds? And this is a bit like what I'm trying to converge upon is that
the speed of light through different mediums.
Speed of light through different mediums, redshift and Doppler shift being associated with the speed of light to obtain distances in space. So I'm not saying like the moon is like 10 miles away, or I'm not saying a star is not a trillion miles away. But I'm saying, is there this kind of thing where it kind of, from the point that we're looking at to the other point that we're looking at, is there this kind of stair-stepping effect of the so-called speed of light? So is it not just this one ubiquitous measurement that's like, no, it's two light seconds away, that's it. Speed of light from point to point is exactly the same, versus when you get up close to a planetary body or a star, light is actually diffracted so heavily because it's dense and it's near the point.
Obviously,
source.
This happens every day, in case anyone doesn't know. That's the reason why we have sunsets and sunrises, because the sun rises after it rises. Like the sun rises,
right. Yeah, but we see an angle.
It rises again for real. Like if it was on the moon, it would be not there, not there, not there, there. But because of the fact that we have a very thick atmosphere, generally speaking, compared to space, we see the colors come in, and they're coming in certain ways. And the reason they're coming in certain ways is because certain light waves bend more than others. That alone indicates that there is optical refraction going on in the universe, which is what Dr. Dadi implies, that there is actually something else happening here. Well, he damn right says it, like, so that implies anything.
Yeah, so I just wonder where we can move from, like, Halton ARP, and from this whole concept of like, of really gravitational lensing not really being a thing, but more so it's light moving through dense mediums.
Well, I wouldn't refer to it as dense.
Different mediums.
But basically,
yeah.
No, go ahead. Sorry.
No, that's it.
I was going to say that
there's a very interesting thing. I've been studying on this particular distance thing, and I was trying to figure out why the physicist guys decided that they were going to break the rules of light in order to multiply the distance of the universe by 3. I mean, why break a physical law that they are, in love with, in order to just get something to be 3 times as large as it would be without it?
Quasars?
It doesn't really make a lot of sense. Huh?
Are we talking about quasars?
Well, no. I mean, just the whole size of the universe.
Well, yeah, but at what time? I hate to be rude,
at the very beginning. At the very, very beginning was when they break the law of light.
No, at the very beginning, there was only we didn't even know that planetary nebula were other galaxies. We thought there was only the Milky Way. That was it.
Well, yeah, you're talking about history.
That's what I'm talking about, obviously, yes. I want to know when in history are we talking about, like when they say the whole universe, it changes.
Well, yeah, it's this is brand new stuff for even them. Yeah, I mean, in the 20th century. I don't know exactly when they decided how, when the Earth was 93 billion light years across. I don't know that, but it's really too odd for me for them to break a physical law in order to just extend it for 3 times. It doesn't make any sense.
Well, so they always do that. That's something I used a hyperbole there, but they do that often because they are trying to balance several different theories, and they think they're being smart, and they're trying to balance the math.
Yeah.
I mean, and they have to basically say, well, like for example, the first problem they ran into that I recall was they basically calculated that the age of the universe was 13 billion years based on whatever dark matter stuff. And then they calculated the age of stars based on quote unquote known stellar evolution principles, which were written by Eddington, which were just made up basically with no tests whatsoever. And because of what he did with Einstein there in 1919 on May whatever it was. Now, looking at the light bending. Now, in that instance, in that book, and tells him that the stars are 20 million years old, or 20 billion years old. So you're having 20 billion year old stars in a 13 billion year old universe. Now you're seeing the problem they ran into.
Yeah. The main thing I wanted to talk about was that if they're wrong, and I believe they are.
Well, your beliefs have nothing to do with it.
What they consider a light year, which it's like 63,000, 63.25 AU across.
Mm-hmm.
If they're wrong by threefold, that means it's 21,000 AU across. Actually, what we're seeing with our own eyes and what they're measuring with.
Are we talking?
But then if you take Hart and ARP,
right,
all of a sudden it's a 10 or a 100-fold difference. Now you're talking 6,300. Now you're talking 600. I mean, you're talking about 21,000 turning into 2,100. And now if it's 100 off, you're talking about 210 AU across for every light year. And then if that's true, if the more conservative is true, then they should be seeing more proper motion than what they're saying they're seeing, and we should be able to see a lot further out, and which means to me our eyes are not actually seeing what is going on. It's like quantum's blinking things in and out, and our bodies are not allowing us to see what's truly going on. So
I don't think that's the case at all. As much as I understand, I think I understand why you're coming up with the numbers you're coming up with, and that it's appreciative of, and I have no problem with that. But I think that if you recognize the problems they're having and you go through it step by step, recognizing the understandings of the electric universe per each issue, you will find that there is answers available every time we go through it. And one of them, for example, in this case, is that the quasars don't happen to match the expected spread from the Hubble constant, basically luminosity and apparent distance, or apparent brightness and something else. I'm not sure what it was, but anyway, that's gives you the Hertzsprung-Russell diagram type of thing, and gets into what type of star this is. Anyway, that's not irrelevant. Actually, go ahead, sorry.
Can we elaborate on that, though, a little bit? I mean, it is complex.
Sure.
This is sort of what Pierre-Marie Robitaille is talking about.
You know what? I don't really mind that, since I like shooting the breeze before the show, before we actually answer this question anyway. I want to do that every time. So this is perfect. Bring it up. What's going on with... Tell me more.
I mean, let's talk about it, because you're basically just on the brink of talking about like standard candles and Cepheids.
Yeah, tell me more about this, actually, because I know what I'm thinking about. So I'll just jot this stuff down, and you tell me, and I'll try to keep up with you.
So I think I'm hearing what James is saying, and in terms of like I've always really kind of considered what the implications of, let's say, quantized light or spectrum shifting, mass spectroscopy, basically radiogrammetry, and then also using standard candles, so to speak, so apparent brightness. But if you're looking at it through the lens of the electric universe, flickering and brightness change can be attributed to different things, right? Because the ether is actually charging these stars, versus these stars generating heat and light from a core, right? This is a completely different inverse concept. And so we live in mainstream cosmology. They talk about it as if the stars were producing energy from their core. Therefore, this is how they're shifting light. This is the radio emission, the bands of emission they're producing. But if we're looking at Sapphire Project, we're talking about like arranging elemental particles according to dense layers of plasma and potentially quantized double layers that we see in the, like that kind of shell around the Sapphire Project anode. But imagine that around Earth, we have the same thing around Jupiter, around Saturn,
yes.
right? This is very organized layering.
Yeah. Except that we have tails, because it doesn't rise by heat like it would with a candle. It's rising from electric potential, so away from the source of most of it, which would be the sun in this case.
Right. Totally. Exactly. They look like teardrops.
Yeah.
But essentially those layerings look like have organized distance, let's say, between them, and they also have organized form, right? They're gradiated layers. And then overall, the layers themselves together make up one large gradiated layer, right? So this is the fractal nature of it, the recursive nature of it. So point that I'm trying to make is that, like, I don't know specifically, but I do know that these are the two ways that they measure, that they, the so-called they, measure distances in the proverbial they.
I'm doing bunny rabbit ears, yeah.
Yeah, measure distances or the expansion of the universe, not just distances to things, but also like exoplanet research, or the size of our galaxy or the solar system or the universe, the Laniakea structure that I just saw a whole video on, this reconstruction of the root network,
or the
local supercluster.
Well, yeah, but that also, doesn't it have a double? Like it has a mirror to itself or something? Like anyway, I'm just.
Well, yeah. No, it's all good. You could pull it up.
I'm looking at it now. Don't worry.
Yeah. Mm-hmm. Anyway, yeah. So how do you gauge standard candles, right? Mm-hmm. In our new understanding of it, because it's really from the 20s. You had Shapley, I think, is the one you were thinking of, James, maybe Shapley or Curtis was working on this stuff in the 20s, and I think it's 100 years later, we should probably have a look into like space distance, mass spectroscopy.
And obviously, there's some falsifications.
Right. And there's and then Pierre-Marie Robitaille is saying, hey, like, yeah, they're measuring all this stuff, but they're basically introducing a bunch of variables to even out the results. And we've heard this, countless times.
Oh my God, that's the same stuff they do with,
I'll shut up now.
Magnetohydrodynamics. No. It's basically, they change math. Could you imagine if I could do that? I wish I could do that. Guys, imagine this. Here's an engineer. You know what? I'm having trouble with I can't explain what's going on here. Well, what do you suggest we do? Well, we could investigate more deeply, but that would challenge my beliefs. So I think it would be best if we just make up different math to describe this. Really, that's brilliant. What a great idea. Could you imagine if I did that as an engineer? Just basically just decide to ignore a whole whack of stuff that I from another science and say, no, it works like this now because of no reason whatsoever. That's what they're telling us.
Or there's a school of thought that cannot be questioned, or everybody is trained in that particular way of thinking, so that there's no really deviation from any of the herd at all. And then if anybody who does deviate from that herd, they can't get in the club for some reason.
Well, that was basically what my entire video was talking about, and the over rigidification of sciences. But let's get going on to this. You were saying, Chris?
Yeah. I mean,
about what Robitaille said. What's going on?
Yeah, I mean, let's move past that, right? So Robitaille is saying, and he has his. I mean, people probably know him in this chat, but if you haven't seen Sky Scholar's
I'm going to find more. Yeah.
Yeah, Sky Scholar channel, and he invented or was co-inventor of the MRI resonance machine. And so anyway, he has analyzed the cosmic microwave background radiation imagery. that has been brought in over the years, especially the recent stuff. And he's saying essentially there's a lot of fudging going on. That, in a nutshell, he's saying, hey, like these numbers don't really show much because the amount of data being thrown away is like 85, 90% of it. And you can't really accurately gauge, you know, what happened a trillionth of a second after a theoretical event by basically fudging numbers like this. I mean,
and
without
they do
going
that a
into
lot.
too many details.
Well, no, that's
statistic. They do it a lot.
That's statistically the same thing they're doing with what was it? Global warming.
Right.
I mean, and I mean statistically modify it. I'm not. It has nothing to do with, by the way, whether or not you believe some political party or some person or another. I'm not referring to that. You can still believe whatever you want, but what I meant is that the numbers themselves. I mean, when I was in school, we learned very clearly what the medieval warm period was and why it was important and what happened afterwards and why we invented such things as doors, windows, fireplaces, putting tapestries on walls because it got freaking cold. So, and it stopped everything from going out to Greenland and stuff like that. So basically it cut off the New World. Well, a few hundred years later, some guys hear some tales. Hey, I heard, no, yeah, this guy's grandfather's father went there. He went across the sea and came back, and he said, yeah, there's lots of land over there. They make grapes. And lo and behold, here comes Christopher Columbus. Gets sponsorship, and away he's off. But that's because they already knew it existed. Well, this is in the same sort of situation. They're doing it too, but they're pretending that they're doing what Christopher Columbus is doing, which is basically, once we get there, we will know everything. But that's a fallacy. You don't know why you're getting there. You'll not understand even what you're even there. When you get the information, you won't know. And this is exactly what they're having the problem with. They see new information and they have no idea what to make of it because it doesn't match their predictions. Because all of this is just basically, I mean, I appreciate that they're doing good research in the sense that we have telescopes that are giving us data, but they might as well take all their conclusions and just chuck it out. I mean, look at, this is an example of what you do when you do with filters. And I'm doing the same thing with this audio right here. Great for audio, not so good when you're trying to determine data points. Like in the sky.
Another one would, unless somebody has another thought.
I'm displaying it on the screen right now, by the way,
Rick,
about PMR is doing.
The idea that the herd or the head of one particular guy would determine what black box or whatever Robotov was talking about is that they're fudging with Kirchhoff's law about the black box.
It's another Kirchhoff's law problem, yes, which is an electrical statement, more or less.
Now how can anybody have dogma about that? I mean, just, you know,
considering we use it all the time. And by the way, you'll learn what Kirchhoff's law is directly if you go ahead and watch that thing from Walter Lewin on electromagnetism. I know that's probably the first time you looked at it, you were like, oh my God, this is complex. I have to learn calculus. But go to the parts where he's demonstrating and explaining, because he's a very good teacher, lecturer anyway. And he'll actually put his money where his mouth is. Like, if I let this go, will it hit me in the face? You know? And he knows it won't. And because we, especially in engineering, have to do things the way that they really are. You can make certain idealized situations, which you do because the numbers won't matter at that point. But if you want to know, I should be able to calculate it right down to the last iota, right down to 9 decimal places. And you can't do that. Like, I mean, even a mechanical engineer can tell you, at this temperature, that will hold that much weight, and if I torque it with this much force, it will break. Period. You know what I mean? And that's what we are designed to do. And these people are playing with the numbers like they're just adding shit together and pretending it's real. And I can't tell you how much that really bothers me, because they would all be fired where I come from, you know? Like, you can't do that.
Let's jump to an analogy here that I've been trying to, because this happens all the time, right? It's not something that can be systemically changed, right? We do it with grading curves with teachers. They're like, no, everyone got a B. But like there are people who got A's. There were people who got straight A's. Anyway, I just saw like a World Science Festival thing with Brian Greene, ex Elegant Universe dude, works at Columbia in New York, and just wanted to see what the state of quantum was in 2020 or whatever, 2019, just to see what they're talking about.
Sure.
And they do the same sort of thing. They're like, here are all these tiny subatomic particles, and we're going to break them up again into these other tiny subatomic. And I'm like, you don't realize that, like, this is what Pierre-Marie Robitaille is saying. He's like, you'll never know the distance. You'll never know the age or the origin of the universe.
Yeah, be okay with that.
Yeah, be okay with it. He's preaching Zen in a way, oddly.
No, it's not Zen. It's science. Like, in my brain, it pisses me off because
comforting and calm. It's like, be okay.
Well, okay.
Anyway,
okay. I'm with you there, but obviously we've all raged over an engine we couldn't fix or whatever. But so obviously it's not all Zen. But the truth of the matter is that it doesn't care what you think. It has to be real. That's what it is to me. Like, I'm describing it the way that I think about it, and I think of it like an engineer. It doesn't matter the scale. There's no, like I said, there's no, light might have time to travel point to point, but electricity and electric currents don't have any of that. They flow in circuits, and that's it.
So why is there a phrase? Why do we know of a sentence that says scientists think this is what happened a trillionth of a second after the Big Bang? What is this? Where did this phrase come from? That language is sinister. Is like, it's crazy to me when I read that sentence nowadays. Actually. It's pure madness.
Well, you
but
can't.
It's ubiquitous. It's popular. It's there.
You're going back. You're going with it's basically you stopped doing science and you started doing preaching or something, or
it's word salad, and it's
no,
done
it's
on
not.
purpose.
No.
They don't mention that it's theory for a reason. They don't say that what the scientists theorize. Well, they used to, but they don't anymore.
Look, like, you're getting all sinister. Let's not think sinister. As much as you guys like your sinister, let me just put it to another way that's not so sinister. I obviously believe this, and I understood it when I was growing up. When I was in, a smart young whippersnapper in the 80s, and this is, to me, perfectly reasonable to talk about Einstein and all the cool stuff, and I could explain it right down to the details how it all works. The trouble is that I didn't understand forces or how to make things work. Like, you can't just say, well, it works because of this. Well, what I didn't understand is they basically went something magic, and they added that middle part in, where they just basically, and of course this is again the same type of proof that Stephen Carruthers goes on and on about. He says, your math is wrong. You're taking this, meaning this, and it doesn't mean what you think it means. You're combining these two things, and they're actually related to different numbers. But people who only see numbers, like only see variables and say, well, it's a K here and it's a K here, we can cancel them. No, that's the K of the planet's surface. That's the K of the atmosphere. You know what I mean? But they'll mix those together.
Neil, I'm literally saying that video, the reason the little nerd group in the comment section of that Stephen Carruthers video loves it so much, he's one in billions, I guess, first time ever to say, hey, this formula right here, math salad, ridiculous, doesn't mean shit.
Doesn't mean shit. Exactly.
But it's really difficult. I mean, look, I consider myself semi-smart. I would have looked at it and been, like bamboozled by it.
Me too. The only thing that's happy for me is that I understand. Like, it's always my professors who are into engineering were incredible, where they said, you can't put that in there unless it's real. Like, unless it's actually, this represents, like, every single thing on a circuit represents something, so I can make a formula with everything that's on there. If this is an inductor, it has an L value. You know, if it's a magnetic field, it has an L value. Okay, so I can tell you how many henries it is. If it's a planet surface, it has a C value. That's how much capacitance it is. And I can start doing this and then writing this whole circuit down. That's how that's how you figure crap out. That's how you do what's called a nodal analysis, or otherwise you troubleshoot a circuit. Well, if this is what I'm doing, and I can basically derive a lot of these variables with more formulas that I already know, and I might be off a little bit here and there, and I don't plan on putting any mathematical constructions here. But the point is that when I'm done, every single thing I'm referencing is a real object or a real force. And they're just skipping shit and leaving it out. You know, or streamlining or something and pretending that it works this way because the math is easier, or it works better on our computers. And you have to admit, you're not doing science anymore.
So, I mean, like this whole, I know, because like I watch a lot of videos and I read a lot of comments. It's kind of like, who was it? Eric Weinstein talking about this 3D geometric unity. But the language around it is so obtuse, and it's really just like word salad, right? And it's hard to gauge whether guys like that really believe what they're saying.
I think sometimes they do.
I think so too. I really do.
And I mean, I don't think that anyone who's preaching the Big Bang thinks that the Big Bang doesn't exist. I don't think that Bill Nye, the science guy, thinks that global warming is a hoax, and he's just doing it for some sinister thing because of guys in a back room somewhere with trench coats handing him cash. Like that's
but everyone thinks, right? Everyone, like, there are days that go by, years that go by, like, well, crazy storm. Yeah,
that's just Bill the electric view agreeing with me. I'm just telling you, okay? Anyway, go on.
I don't disagree that he believes a lot of it, but you know, it's just like
he must have doubts sometimes. But you would be amazed at how powerful groupthink is to keep going along with it.
I know.
I mean, I would challenge myself. 17 or 18-year-old me would mock me, and the trouble is, the only reason I don't mock Dave is because I've been where Dave is. And I can almost feel the laugh, the sort of, you have a nervous laugh about you. That's what I feel from him. Sort of like, ha ha. But he might be just like, I opened a can of worms and these guys are crazy. Or like worse than the flat earthers. He could be saying that. But he won't hear any sort of evidence. The only way is to, you can't convince him with evidence. It's not an evidence-based process. It's a human being-based process. And
but what does he get out of it? What do debunkers get out of debunking theories?
Sometimes they think they're doing a public service, although I can't see anything that he would say that Neil deGrasse Tyson hasn't said. You know, he's not bringing anything new. He's basically going, I need to set these people straight with all my learning I learned in school. Boy, these people tick me off, just like I am ticked off right now. The trouble is that my ticked offishness is about scientific process. He's a master of arts or something, or I'm not sure.
But he's saying, but all these people who debunk, let's say, even people who debunk flat Earth, so to speak.
Of course, I don't debunk flat Earth. I just challenge it when it's presented. You know.
Just
whatever.
The process of doing a title in big letters saying I'm about to debunk something, it makes me I don't like cringe culture, but it sounds like the Bush campaign came up with it. It sounds like propaganda to me. People use propaganda ultimately because they appropriate it and then they end up using it themselves unknowingly, maybe.
Yeah, that's why there's evil memes out there that are like make you feel uncomfortable, and you're like, wait. You're not speaking a truth, you're speaking a spite. You know what I mean? You're trying to be hurtful. And that's why humor and sarcasm tend to be things of truth. Because you can't be funny and untruthful at the same time.
But you listen to Crothers. Speaking of Stephen Crothers, really doesn't get enough attention. His type of humor is funny. It's snark. There's a
yeah,
way
I
to
love
be
that guy.
witty and snarky, and to the point where, like, when he's
But
baking
not
Einstein's cake,
mean.
you're really belly laughing. So
Yeah.
this idea of having to debunk these people who basically, I'm just lamenting a scenario that I know won't go away, but people who think they're debunking are just really lame. It's just really lame.
Well, and that's why
Don't feed
I
the
don't.
trolls.
Well, there you go. And at the same time, though, in the same time, I answer questions often on many different subjects on the comment boards and so forth. And someone goes, "Why are you wasting your breath?" I go, "I'm not talking to the person I'm talking to. I'm talking to the person reading it right now. Like, why are you standing up? Why are you saying this?" Because somebody somewhere needs to hear this, and they're not as strong and amazing as we all are, you know, or whatever. No matter what the reason. But if you're talking about flat Earth, I tend to talk to. I'm not talking to the flat earther. I'm talking to people watching. I'm not talking to Dave. I'm talking to people reading. When they see my comments or they watch my video, I don't want to give Dave any credit. I even mentioned his name very slightly in one video accidentally. But at the same time, that's not what this whole thing's about. It's about showing the crux of the matter and why your faith in the system, you really need to study human beings more. Because that's not how we work. And we're able to fool ourselves so much that we can have hallucinations. Trust me, we can fool ourselves. Better than anything else. We are the best foolers of ourselves. We could fly a plane into a cliff if someone said, "No, that's just a projection there. It's not real. Just sit back, relax, have a martini." No, we're actually doing a movie shoot right now. And I bet you dollars to donuts you could probably pass 10 minutes off making bullshit up before someone actually kicks you out of the friggin' way and takes control of that plane.
I think it's like if you point something out. I'm not saying pointing stuff out is bad.
No, it's good. I always encourage people to think.
Yeah, there's a way to present something. I just mean, like, I think it's so. Like a week ago when I did one of my last recent shows, I did talk about flat Earth for a bit, which I don't normally do, right?
Mm-hmm.
And I do it often because I know there are people who watch my show who are flat Earthers. But
I should do a show on flat Earth.
Well, what I was going to say is
I don't mean in a really mean way. I mean in a constructive way that will help people see some of the very basic arguments and show you how to navigate yourself on a planet and why we learned that the planet was round and how we did that. Simple things.
That's actually what I was. That's a great segue. I didn't even. The reason I consider flat Earth even a thing is more psychological. Is like, why are the statements used by flat Earth adopters similar to these kind of trillionth of a second after the Big Bang, similar to Professor Dave debunks blah. It's this way. I'm talking about how language.
Oh yes, I am a very big
so
master of
theories.
language.
The concepts themselves are the concepts themselves. I mean, literally, somebody who tells the kind of smugness of debunkers or people like Joe Rogan or whatever.
Well, sometimes Joe can be very nice, where he seems to be honestly going, "Whoa, really? That sounds amazing," and other times.
People are going to hate me for saying this, but that's why the Rock is popular. But is he a good actor?
Like, I don't know. That eyebrow is amazing.
But I'm saying charisma and looks don't a great actor make.
No.
And science and pomp science, Nobel prizes and big hugs on the Mars missions don't great science make, right? So is what I'm sort of coming from is like the tie-in between flat Earth psychology and pop mainstream religiosity and science and so-called debunking the crazies is the same sort of thing. And in a weird way, like I was watching Eugene the Philosopher, and I love Eugene, he's brilliant. But at the same time, Eugene uses language that belittles large groups of people while also admitting to having been belittled. So there's this very interesting dynamic between self-blind awareness versus being very aware of everything around you. And that's why somebody like Professor Dave cannot have his own awareness of knowing that he will not know everything.
He can't.
And then presenting things as if.
Let me present the idea that debunking is a godhood delusion, because you have to know everything to know the ability to say it's not possible.
Yeah.
And the other thing is that you're talking about you're someone on a plane and somebody's telling them bull, and it takes them a while. Well, that's because that's our greatest strength, is to be able to, to play, to project into the future possible outcomes without actually physically doing them, to find out what was the best course of action. That's our greatest strength.
Well,
So
actually, and that seems to be something we all learned.
Too.
Like we said, we talked about that.
Yeah.
But.
Well, I mean, that's why people go along with it, because they're going to say, oh, he's playing, he's trying to figure out a better way to do it. Oh, no, he wants us to all die.
Right.
It sometimes takes a while to figure out which one.
Well, and that's what I mean. It's charisma and the ability to convince people that they're full of crap. I mean, that's just a verbal gift that, me and Chris Kelly have spoken about this at length. And perhaps it comes from upbringing, childhood, family size, interactions of different sizes, maybe. I don't know. But encouragement, self-esteem, I'm sure these all play factors. But
I mean,
go ahead.
I mean, take a band, for example, or take a group of scientists like Monty, right, and the Sapphire team.
Mm-hmm.
It's always better to uplift your teammates or not work with them. This idea that somehow we have a political system where people are antagonistic, or a science community on YouTube where people are just pointing fingers and saying, like, fuck you, you suck. To me, is when I say lame, and Shockwave, you're like, don't feed the trolls. No, I'm just commenting on the psychology of being in this environment, wanting to really talk about like how NASA does have a plasma physics department. They acknowledge most of these concepts. You know what I mean? They really do. Like, if you, there really is a moon program. The people who are interested in flat Earth are actually kind of interested in the moon. It's seductive because there are certain factors that are not like, so kind of what I want to say, which was flat Earth was never about the shape of the Earth. It's always been about what I wrote in the chat, which is it's so easy to say, it's all bullshit, I'm out, versus saying, you know what, it's all bullshit, but like we're on the same team. We got to work this shit out, guys. That's really all to me. Like it boils down. Same thing with the Professor Dave thing. He's out for science. You're out for science, Neil.
Of course.
Why can't we get on board for science as opposed to like, got to tell you how you're wrong, bro. You're wrong. Wake up. Jesus is coming back. I'm like, hold on. Like we're on the same side here.
Well,
so
see,
anyway.
Yeah. I was involved in that conversation in the live stream chat, and I found something that the Zoroastrianists, their creation story is pretty amazing. The first thing that was created was the egg. The second thing that was created was the water. Third thing that was created was
the golden egg.
Was a flat Earth that floated on the water.
Of course.
That is probably where the flat Earth originated and
actually
be thought of.
Yeah, I would have to agree with you that the flat Earth, in my opinion, has its origins in the axis mundi or the polar configuration.
Right, and that's
in so much that, if I may finish, that the rings of the planet would be something that we would have seen without the moon to destroy them, and they would make us appear as if we were in a bowl. If you were in the northern hemisphere, you would see these 7 rings. There was actually 9, but they were very faint on the inside. So if you were on the inside, like really close to the equator, like the Mayans, they called them the 9 thrushes or thrushes or something like that. That's what they called them. And I'm sure that has something to do with it, but most of us would refer to them as the 7 seas. And it was the river that you must cross to go to the land of the dead, which was to the south.
River Styx.
Or where Charon, the boatman, would carry across, the Grim Reaper. All of this is all from that imagery. Now, it would appear that we were in a flat or bowl-like shape, and then there would be like a mound on the northern pole that would be a cloud bank that would look like the back of an elephant or a turtle or something like that. And then this would stick up and out through the top of it like the helm of one of the Kaiser people from World War One. And this spike would be going up there, and then it would be,
Can I finish the creation story?
No. I don't want to go too much into it. I simply wanted to say that I was agreeing with you, and that should give an image of why I think that the flat Earth is something that, I mean, it should not be. I mean, it should be.
They considered the discs, the rings that were around the Earth as
Well, yeah,
water.
Midgard, Asgard, yeah.
I understand, but the story goes, or the creation
The
story
Watt
goes,
Absu,
that the next creation was a tree,
Tree
basically
of life,
the tree of life.
Jack and the
and
Beanstalk.
It was destroyed by fire that permeated all of the creation. And that fire
a big conflagration.
we know today as plasma, right?
It just became
So
unstable.
it permeated the whole system and became unstable, like you say, and
Had to rebalance.
the tree, how life came to be on Earth was this tree was ground up by this process and fell to the Earth and spread life on the Earth.
Well,
that's what they say.
It doesn't really
That's
matter what they say, because we were made underneath that tree in the Genesis book, but there, according to the Native American tribes, many of them believe that they were shaped from the clay or came out of caves from that northern area.
Well, that's the Bible, and that's the Sumerian story as well, shaped from the earth, the clay of the earth.
This is because they probably saw giant wisps and tornadoes and stuff sort of moving and then fading downwards. When someone died, they probably saw a light go up the tree, and they would go, "Oh, that's his soul. That's that guy's soul. He just died." And oh, well, pray to that light now. Okay, that's him. Everyone feels at peace. We feel at peace. I feel at peace. I definitely feel at peace. Well, this has been a great service, guys. Thanks for coming. So this is what I'm seeing when I'm dealing with that kind of stuff. Human beings must take into account, because obviously we were here watching that. We couldn't have been made by it. You know what I mean?
We if we didn't witness the creation of the so-called universe, which is really the creation of the solar system that we're in, the reordering of the solar system as Saturn came into it, we witnessed it. Humanity witnessed it, and we called it creation, the birth of creation.
No, I'm aware of that. Yes, we know
Most
that.
people don't understand that. That's what I'm explaining.
Okay. Yes, okay. But still, anyway, that I don't want to talk about Big Bang, or big flat Earth, but anyway.
Well, I would just like to add that I talked to Sean and posted about this, and he said that the Grim Reaper is the guy who takes you from the Earth to Mars to the land of the dead,
right.
Is a Christian, modern Christian. That's what he was. He didn't believe anything that went further than that.
Yeah, the Grim Reaper.
I assumed that it had been very ancient and old, but
well,
he disagrees with that.
I don't have to. I mean, number one, it's a Greek myth. So, what do you want me to say? It's Greek, at least. So I don't know what he's talking about. I mean, Charon is Greek.
Well, Charon, but they didn't call it. They don't call it Charon today. They call it the Grim Reaper, which is a different thing. But it's the same.
Well, guess what? They don't call it a death grip anymore. They call it a mortgage, but it's literally the same word in French. Okay? They don't walk up and say they got you by the balls. Like, they don't say that now. They say you have a mortgage.
Well, it's the same thing with myth. It used to mean history, and now it means fake news.
Well, right, but yeah, and that's fine, but it really has nothing to do with the nature of. Anyway, look, this has been fantastic. how about we
Wait,
talk some of the people?
One
and
last point.
One last point.
Point
Okay,
about
okay.
psychology of it, because Tess is talking about like how masses are made to believe in flat Earth. I agree that, like, we talked about how culture comes head down into the masses. I personally believe that. I've talked about it. The point that I wanted to make, that it wasn't to go into flat Earth about whether it's right or wrong. It's more about like how similar the word salads are and the math salads are when it comes to selling people.
Oh my God! I mean, I know what to say to convince you. Yeah.
That's all it really was. I just want to make that really clear. Like, I don't.
It's a nice to estimate, and I'm concerned about that. Believe it or not, like I'm very concerned about the power of my voice. Now with a new microphone, perhaps I will somehow use my sumptuous voice to attract new people with hypnotic whatevers. You know, like
yes. Of course, it's very important. I mean, you're carving geometry into the ether, one slice at a time.
Well, if the ethers are considered in this case our mindscapes together, yes, are
okay. Like sun has like campfires. Who decided that?
Who decided the sun? Who decided the sun was a campfire?
Okay, in 2020. Sorry, I went too quickly.
Thank you.
2020, all the science about the sun, Parker Solar Probe, Pierre-Marie Robitaille, dozens and dozens of years of all these different imaging of the sun.
Right.
They're aware of plasma, yet somehow there are articles today on phys.org that say, oh, little campfires on the sun. I'm like, that's insane to me. Like, who's writing that? The editor, the science chief?
Little campfires. Yeah, they're each one the size of a planet. You know, like.
But I mean, just the word campfire is so manipulative to someone like me. It's not manipulative to a dozen other people, but you can really see through it. It's like Crothers going through Einstein's equations and explaining it. To me, seeing campfires in association with a science that we are certain of is actually plasma-related, magnetic field-related. Saying campfires, very manipulative. Anyway, just want to say that.
Did we and you have, or you and I have a dispute about what was his name, Richard Feynman and his description of magnets? I'm not sure if it was you. Anyway, no, it turns out that we both had different opinions. He said he's being snobby, he's being this, and I was like, no, he just doesn't. Look, he can't explain certain things to you because you just simply, analogies are analogous, but they're not reality. And look what happens when we draw lines in a piece of paper. These guys thought the lines were real. Like, seriously, like, we can't trust them. They should be not allowed to do this stuff.
So I'm saying, do we think that, somebody just mentioned Anton Petrov, but it's the same thing with Vsauce or 2 Minute Science.
It is
or
a fiery
PBS.
wall, yeah.
Yeah, but this idea, this language is so either primitive, it's very like 16th century, or it's
at least it's fiery because
chief.
In the sense that it is a wall and it is fiery a la plasma, but that is sort of, yes, you're right.
Pull up a picture of red sprites. Pull up a picture of red sprites and pull up a picture of an actual fire. Nobody would make that discernation.
I don't think he was talking about sprites. He was talking about the heliopause.
But I would imagine the same way we have red sprites and green sprites and this layered, very thick lightning bolts, basically, in our ionosphere, why wouldn't it be the same at the largest scale?
It's because it's very diffuse. Have you ever taken a plasma ball like the one that's on the screen there, and crack it and let some of the air in? Well, when you do, it the streamers become wider. And as such, if we're thinking about this as electrical pressure, if we go all the way out to making it, like, if I just keep the same amount of current but keep expanding this ball in size, larger and larger, it will just keep getting bigger. And basically what will happen is that these tendrils will eventually go into dark mode and you won't see them anymore. But then they'll be fluctuating in sort of like pulses. It would look like if you could film it over a long period of time and then speed it up, it would look like a fiery wall, like sort of rippling with with potentials moving back and forth, trying to basically move potential charges outwards from this solar heliopause to the next place, or take them in, vice versa.
Look,
It's
fire is also plasma. I'm not
Exactly.
unaware of that.
No,
I'm
but I just
saying,
meant all I'm saying is it's certainly better than campfire.
Either way, somebody chose campfire is really
That's
my point.
really
Like I always
terrible,
I'm trying to stay on the
Yeah.
on the real psychological side of it, because all these theories, yes, are their own rabbit holes, right? But
Well,
like,
yeah, I have a
but
whole
really
whack
more
of them
so
across
than-
in front of me, and I can't even talk about them. So keep going.
So actually, I mean, you would imagine, or maybe I'm wrong about this, but red sprites to me look like they would melt metal, right? Versus like a lightning bolt that maybe wouldn't. Or am I wrong? Would it be less? Would it be more diffuse? They just look more scary.
Oh, actually, they're, in my opinion, they're much more powerful than, like, basically they're the entire storm below barfing upwards. And for a split second, that's a high amount of current. I mean, that's just a severe amount of current. When you think about the fact that it must be covering how big an area, and you can see that this area that you see it in right here is a pinch. Like right here on the screen now, which is hopefully
Picos Hank, that stuff these guys just recently did. I showed it, or at least I linked it from my
Well,
channel.
no, but this is a good shot for what I'm trying to
So
demonstrate.
good.
Is
Yeah,
that it
that's-
has an hourglass, like this right here is the pinch part of the current, and so basically this is the bottom part of the squatter man, and up here would be a larger part where it's fanning outwards. This is where the current went through and bloop, and it lit, and as it goes through these areas here, it goes past this level of plasma and it gets incredibly diffuse, like I was describing.
Okay.
So that's what's going on right there for a split second. Although I'm very interested by this image, though. Makes you wonder if people saw these sprites sustained and freaked out. Because there is an argument to be made about that.
Well, yeah, that's what the depiction of
No, sustained
thunderbolt.
Yeah.
Like, I mean, that's an hour, that's a pyramid with a star on top is what I'm talking about, and it's a sprite. So do these get naturally formed in the atmosphere? Is that why, like, Nambia is just covered with these tall, thin pyramids, just like this? And they glowed at the top, just like the old pyramids did? You know, like, I just can picture lots of things here. I don't know if any of this is true. It's just how we should be thinking, how we should be approaching the problem. I think.
Let me ask you then, like, how does this, like, Picos Hank have, like, whatever, 4 million viewers, full on, approaching this thing scientifically, and then nothing about it in the scientific community, explaining what it is, how this affects Earth, how it affects global warming or whatever, climate change.
Well, you're
how it affects
basically
space travel.
you'd
No,
have
they don't
to-
even recognize it. This
no,
is basically
they have to basically say that they think that the Earth is charged by the sun, and that the impact of all these charged particles is what's charging the sun and charging the atmosphere. They basically have the entire thing completely backwards, number one. Or number two, they would be wise enough to realize that in electricity, you do not have isolated pockets of anything. Everything is occurring because everything's in a circuit. They charge up, they discharge. They charge up, they discharge. And this is going to happen all the friggin' time. What happens
That's a
underneath?
Short circuit. That's a short circuit that we're witnessing right there.
Basically. Yeah, okay, yeah, that would be
Between
fair.
the double layers.
That would be fair to say.
And
that
it's exciting the nitrogen and causing it to glow red. If it glows green, it's oxygen.
Well, and the reason that it's high current is because of the filamentary nature. We talked about this if we go over here and we talk about this, the plasma, this is a good segue, by the way, into the question. But first, I want Rick to talk to the audience there. But what I'm going to do is that plasma curve. I'm trying to remember what it's called. Plasma. What is that term for it? The plasma VR curve? VR curve. VI curve.
Is this the main thing that the theoretical physicists get wrong? Is
There it is.
as far as current's concerned?
Well, they don't understand plasma enough, because look, this is an example of what I'm talking about, of how absolutely crazy it is. See,
Oh, you mean the changes from dark mode to glow mode to
right.
arc mode?
But
yeah.
but
Okay,
here's
yeah.
the most important part. So we're in arc mode, right? Probably somewhere in this area, because it filaments, they're getting tighter. So what's that? That's 100, over 100 to 10,000 amps. So that's what each of those strands are, just to give you an idea. Each one of them is that much. Now, amps, to make watts, is how long they're sustained by, like how long they're sustained for. So if you have
A measure of time,
a
yeah.
measure of time, yes. If there is, so we know that this is how much amperage it was, but it was only like that for a split second. But imagine you're in a high-flying airplane and you're going near that, and that happens. Well, have you ever seen something electrically crushed?
Bennett Finch?
Yeah, like a Bennett
T-pinch. T-pinch.
Yeah, but I mean, in a laboratory or something, like an actual crush, because that's that's what they would be going through. Yeah, I mean, that's what they were going through, and yeah, that would totally turn the plane into an accordion. Doesn't matter what you're saying, because the difference in potential would be different between, even if it is a Faraday cage, it would rip any ferrous metal on that plane would be ripped right out of it, and every piece of aluminum would want to go in different directions. But only for a split second. Is that enough to rip the roof off a plane? I don't know.
What?
I think it is.
How many amps does it take to power, like, say, 10,000 or 100,000 homes? How many power stations are we talking about?
Okay, well, if I was using this as, and we're calling this as basic house current, or because it all depends on the voltage we're transmitting it at. Long story short, if I was to say if we wanted to be more fair about what we're looking at, there's an area here, okay? And we could say by the brightness and general size, what we could express what the current is through there. And then we could judge how long it lasted. And then once you do that, then you can calculate how many watts or joules were expressed or energy was stored. So yeah, you could work it out. It's not impossible. You would have to accept the fact that until you got exact measurements, you would have a margin of error, but you could measure it with the light, like light from oxygen being red or whatever, nitrogen, I think it's oxygen.
It's nitrogen red, oxygen green.
And if you had a light, sensor on your thing, and you could take a multiple light scans of that footage, and you knew exactly how bright it was at the time, because this is obviously a prolonged shot. He was sitting there for an extended period of time, looking at a storm over the horizon with this beautiful mountain in front, and it discharged during it. That was his camera managed to pick it up, but that doesn't necessarily mean that that's how long it was either. Like, we only have that one frame to judge by, you see? So it's not nearly as easy as I'm saying, but I'm saying with enough data and just the brightness and understanding how nitrogen works and how bright it would be to glow at that potential, then yes, you could calculate it basically.
So quickly, Neil, two things. One, there's video of this, and the way I think they're doing it is they're running a time lapse camera thing. So it's taking a shot every few seconds, and the shot is probably held open for a few seconds.
Oh.
Like, because you can see the stars, it's something like a 3 to 5 second exposure.
This could be, I was going to say, this could even be twilight or night, for all you know.
But the videos, sorry.
Actually, with the size of the hard drives that are attached to these video cameras, they can run them constantly and just sit there in a certain
Things are
area.
Different now, yeah.
And just sit there and let the footage roll, and they'll capture it, and it'll be put onto a hard drive, and it's pure video, 100%.
This is a good.
There's no.
This is a good example of what I'm talking about. See this right here? We have the sun in the shot. That's really good. So you could use the sun if you actually had depth in all of this. Like right now, it's whited out. So at a certain point, but if you actually had color depth and brightness depth for like 32 billion pixels deep or whatever, you could easily figure out the brightness of the sprite compared to the sun, and yeah, you'd be able to do that calculation.
And I can't remember the name of it, but there is a brand new phenomena that is between the sprites and the elves, and it's a glow, like a glow discharge.
It's green. Speaking of oxygen, what you're just saying. Yep.
Yeah, you remember? Do you remember hearing about that, Chris?
What, Steve?
Yeah. It's
in
the
name of it.
This guy Picos Hank and this other cat had just recently this year did a whole new revived run on these red sprites, and they got literally enough evidence that like anybody could really, who knew what they were talking about, could really derive from it. But they definitely did the. For me, it's about the like the plasma sorting of elements, right? And what we're talking about with the blue and the red.
Well, look at this right here.
So nitrogen and then green glows were experienced during certain sunsets, certain eclipses, and also during red sprite events.
Remember how I was talking about how it was the Waterman shape? Well, take a look at this right here. See this ring that appears over top of the sprites or through the sprites?
Yeah, the elf.
Mm-hmm.
Yeah, that's the ring current. That's what's causing that. That's because there's so much current going this way that it generates a right-hand rule current going around it. That's why that's there. And that right there is a very well-known phenomenon, and the Earth has one. And we call them the Van Allen belts. It's not rocket science. Literally electrical science. Not that hard to figure out. That right there is a way to figure out, like if you saw one of those, you know that the secondary currents are enough to light up the fucking sky. Pardon my French.
I just dropped you the link in the chat if you want to. I don't think it's, I think it's worth looking at because it's just changed. Do you see the chat room?
No, I got it. I'm in here.
Oh wait, am I?
I'm already broadcasting. We're good. Where should I jump ahead? Because I don't want to get.
In the Skype chat, I dropped you a link to the latest video from like a month ago that has footage of these sprites. It's like mind blowing. If you want to show it.
I am showing it. I was asking where I should jump to. Yes.
Oh, sorry. I'm lagged on the live view. Sorry.
Yeah. You should be seeing it now.
Jump to whatever point like you want. But like, yeah, some of these.
I just don't want to get like, it's his work.
Yeah.
And I don't have permission. So.
Teaching time. It's educational.
Well, it is, and if I do little bits of it, I'm being educational. If I do show the whole thing, I can do it.
Don't tell me. I've told you before.
I can do it, but to Gareth loves when I show it. Like, go ahead, yeah, show. So all I'm doing is advertising.
Just skip to like just the green glow. I guess I'm not sure where that is in the video, but somewhere
this one?
I noticed that they had like the ghost. Was it ghosts or something? The new.
I think it was called Ghost.
Excuse me.
I think I was looking for the name. Hang on.
I'd like to talk to the audience, though. Well, wait, Rick.
Again, let's also do that. Yeah, I'm sorry. I derailed us. Go ahead.
I know. It's okay.
Could Chris take care of that while I look for the name of these things? Chris is really good at saying hello to the folks.
Hello, chat.
Hello. Yes, hello, chat. Yes.
Hi, Tess, kicking ass at moderating and making videos. Got Robert Diggins was saying something actually I thought was interesting. Maybe you want to talk about this. Robert Diggins says, in a match flame, the blue is actually coming towards you. And what else? Where was it? Blue is hotter than red, frequency-wise.
That's true.
So does that mean lightning that's coming under the red sprites is hotter?
The trouble is that that's usually in reference to metals and thermal heat. We're dealing with electrical ionization now, so it's not necessarily true because we can have like green flame all using the same current, you know. However, it's the gas that we put in it that would change the resonance that we're getting in it with the electricity. And obviously you want a noble gas so that there's no reactions. That's why we use like neon or xenon, stuff like that. Xenon.
Oh, okay, maybe he's saying it was a joke. Okay, sorry. Let me go back up to the top. I saw something. Let's see.
We're obviously not going to get to the question, guys, but the question was a wonderful one that was put on. The question was, and I'm telling everyone now, why is lava like a plasma? So I'm gonna answer that. If I have to answer it off the show, but I want to get everyone to write something down. So anyway,
here's a
keep going.
question. Frederick Rhodes, what's going on, says, is there possibly more elemental oxygen atoms left in the atmosphere from the solar plasma ions, blue sprites?
I don't know, honestly.
Possibly more elemental oxygens left. It would seem so. I don't think we've pulled it up yet on the video, but the green afterglow could definitely be residual, like, you know, when a current is cut, it kind of releases that shock wave at the end of it, like in those electric plasma like experiments in the laboratory. Maybe that like last blast hits in the oxygen. I don't know. Maybe I'm just talking nonsense.
There's another video, vibrant red sprites and vibrant red sprites, jets, and mysterious ghosts. So yeah, ghosts were the new name for these phenomena.
Mr. Mulligan. This is still
what's going
beautiful.
on Holloway Arts, what's happening Renegade, Ryan and NC. Ryan says, I've only seen aurora twice in New Hampshire. Not much color to them, more white waves of light moving across the sky.
I've seen them many times, and well, 3, 4, 5.
I've never seen aurora.
Really?
No.
Oh.
I'm always going south. Yeah.
It was so amazing, and it was green. But it was so amazing that we stopped the car, turned it off, put the seat backs, opened the sunroof, and just stared at the sky. Like pulled over to the side of the road, and we did that for 2 hours straight. We didn't blink.
This video shows a beautiful depiction of the double layering.
You're getting it, eh? Yeah. See? And look how they talk about the magnetic field. This is exactly what we're talking about. However, this stuff would go bloop, like just like as if, but it would be faster than any thermal reaction you can imagine. Like, because charge does not take thermal time.
Right. Well, the sun provides us what is it? Don Scott says 10 million amps. I'm guessing that's every second of every day.
Well, that's
10 million
how amps work.
Of power. So, it's unquestionable that there is a massive amount of energy being fed into the top double layer of our atmosphere, and it's filtering down in short circuits down into the ground and making its way into the center of the Earth, feeding a plasmoid. That's
what your thoughts are, but I'm not saying that I can't say that's true. I say that's a good guess.
Let me ask something a little bit more tangential. What do you think, and how do you think gravity, or the effect of gravity in terms of electromagnetism, is affected by these layers? Do you think there's less gravity at these points where there are red sprites, or more pull? Or
I would have to say less. And the reason I say that is because of my very limited experience with tornadoes, because they would eventually form the twisting nature of a Birkeland current, and like the dual sheath nature of a tornado, it seems to have a gravitational like effect where a tractor or cows could be stuck to the side of it flying at 500 miles an hour, which makes no sense whatsoever. I mean, they should just go flying if it's wind. It's not just wind. There's something else happening.
It's something else. It's charge holding them into
the
double layer.
Lets me think that charge is somehow related to gravity. Yes, I think that, or capacitance, and then it somehow is related to gravity. Yeah.
So let's see. So take it one step further. Why does the moon have less quote unquote gravity? Is it because of its mass? Is it because
What
of
is
its
mass?
size?
I would have to say that if I'm right, we don't know what planets are made of anymore. There's no way to just figure that out. We are
Size
only
may-
like, pardon?
Sorry. Size may be a direct result of how much energy is passing through
No.
an object in space.
Yeah, I like this. I mean, this is sort of what I'm thinking too.
Like expansion, like I think possibly, very possibly, that once Venus cools off, we're going to see some magic happen. We're going to see Venus gain a magnetic field
It's
and
possible.
expand.
It's
I
possible.
think we're going to see that.
Those are not beyond the realm of thought. No.
Well, and there's also the fact that, well, I mean, somebody's written a book on it that solid oxygen is electricity. And
Yes,
the
that
Earth
sounds
is
ridiculous to me.
It sounds
So Neil,
ridiculous.
now
It does to
now
me.
in Mars's instance, we have to figure out how can we extinguish a plasmoid? How can we make an active plasmoid which Mars probably had in the beginning?
Oh, I know how to do that.
Can we
Watch.
extinguish it?
Let me show you how. Okay. How
I wanna
to
know.
kill a will-o-wisp. How to kill a will-o-wisp. Okay.
I mean, yeah.
You can use silver
Just-
or magic weapons.
Oh, God.
No, mythology. Do that. Will-o-wisp.
Well,
in
how
mythology.
do you make a planet disconnect from the Birkeland current without heat? That's what I'm saying.
Well, how do you make electricity disconnect from a circuit without heat? Just because the heat can provide a switch doesn't mean the switch is on all the time.
Oh, okay.
It charges up and it discharges, charges up and discharges, charges up, discharges. This is very interesting, by the way. So the term will-o'-the-wisp comes from wisp, a bundle of sticks or paper sometimes uses a torch. The name will, thus meaning will of the torch. The term jack-o'-lantern, jack of the lantern, originally referred to a will-o'-the-wisp. So a pumpkin that we light at Halloween is actually a plasmoid. That's what we're trying to imitate with the pumpkin. In the United States, they are called spook lights, ghost lights, or orbs by folklorists. So that's what there are. They're floating balls of light, or basically ball lightning. So how do you kill them? Let's kill some. Let's see. Fool's
You've mentioned
fire.
the metal rod before.
Yeah, I'm looking to see if it's actually written here. That's my thing. I can find out. Anyway, natural explanations are pointless because they're all using gas and they need to self-propel, but this thing is basically a layer between, like, probably like fog layers, and it's right in between them. You know what I mean? That's what I'm thinking. Anyway, yeah, in literature they just hit it with cold iron or wrought iron. And obviously that makes perfect sense. You would just change the magnetic field and it would destroy the will-o'-wisp. The plasma would be gone. Anyway,
So how did Mars?
Let's jump back.
So
Yeah.
So basically, the interaction of Mars and Venus killed its plasmoid, basically.
well, I think that Mars has crustal magnetism because it never really had a core like we did. It's not quite the same type of planet. It could be a carving of a planet. Like it could be a whole planet, but it could be like literally the surface of Jupiter, because it was just barfed up a long time ago and just carved around. I know it's not. I'm just giving you an example of, it doesn't have to have a lot of metal content in it. Like we obviously have metal in us and we seem to be divided into sections. That's very obvious.
Is it worth talking about, the potential hollowness of everything with like basically an atomic structure?
Same thing with the pyramids now, when I'm starting to realize what they might have been doing with them. Yeah. But that's a whole other ballgame.
The pyramids are just a thin shell with a tiny core.
They're just an imitation of the Earth, in a literal way, yeah. If the Earth is hollow.
Well, let's clarify. Hollow still means that the Earth has a very, very thick crust.
Yes,
But
very,
then
very, very,
then
very,
everything
very
we
thick.
think is molten lava is basically really magnetic, like sun plasma, let's say.
Well,
So
what we consider the very small part would be the inner core, which is less than 1,000 miles across, would be empty space, and then what we consider the outer core would be like a fluid that's being melted by that empty space.
What was it recently that talking about continental drift? I think you were what's his name? David D. Hilster was talking about Earth expansion theory and
Right.
Sure.
It's interesting stuff.
It is.
Let's quickly.
It's called the dissident science
Right,
program.
dissident science. Yep, exactly. I thought
Yeah,
that conversation was good.
I was not on yesterday's show, or in the comments on yesterday's show, but in the week before that, the Saturday before that, I was talking electric universe and how the Earth, when it disconnected from the Saturn and / Jupiter polar configuration, it connected to the sun, and that was probably the trigger for the expanding Earth that made that addition of energy. Because remember now, Saturn, Mars, Venus, and Earth were getting that energy when Saturn came into the sun. They were all sharing that one Birkeland current that was connecting to the polar configuration. When they all broke up,
I think you're making this more complex than it has to be.
Things happened that
yeah, something happened.
disconnect-
Literally says right here, something happened right on the screen. Right, they just said that.
Well, when we disconnected, Pangea got broken up by the thunderbolts that were being tossed about above us, that were hitting the Earth, and the Earth was
I still
expanding.
think that you're making this way too complicated. Basically, the principles to me is that there is a positive and negative charge, and if there's more charge on the outside of the sphere, there's more positive charge in the middle. The trouble is that it's pushing across from itself. There's 800 kilometers. Imagine if it was only 10 kilometers when they started. No big deal, just a pocket. But as the force begins to increase, that's the only force I know of that could literally push a planet apart is the electric force. Nothing else is able to lift so much. And this is shut up.
Sorry, go.
And the pyramids might have been working on a similar type of principle, basically having pressure on the inside and bending granite, create a positive negative flow. I don't think that's beyond the realm of possibility, and we might be dealing with that kind of thing. So it's very compelling anyway.
Well, you see, I think gravity might be tied to electron density. In terms
mass certainly
of mass as well.
But we don't know. We have to actually work at a formula, and that's what I want to do.
I understand. But what
anyway,
the evidence
Chris,
is
what did you want
to... is their last talk was paleogravity, and they were showing us.
So Chris,
I like this. No, I'm with Rick on this one. Like because what I'm trying to look at, right, is this idea of density. Right, I was talking about light earlier, going through dense mediums. What is the equivalent for what we feel as gravity? And then two, how does that tie into how dinosaurs existed, Earth expansion, mass, and then kind of take mass into energy and like Einsteinian relativity. Well, I mean, I have a much larger conceit that I'll talk to you guys about, but I wanted to do a show maybe with everyone where we talked about how and we'll call it everything is right. Every theory is right. Like how to take electric universe and make every theory, every conspiracy fit. And we could talk about how really Einstein's clocks were basically a fractal interpretation. You could interpret them fractally in this kind of plasma bubble.
It's quite possible we could do that. Yes.
Yeah. So maybe a thought like that. But I like this. What Rick is saying.
That's an amazing thought, because I've been finding that everything ties to the electric universe. Everything, history, science, geology. I mean, everything.
Myth, all the like werewolves,
Everything.
vampires,
Yeah.
you know, all the stuff that people,
Mysticism.
superheroes, people love this stuff. I mean,
Mysticism, astrology, it all ties into the electric universe, and the electric universe can explain all of this stuff, and nobody really gets it that it can do that. And it's
look at
wow.
your hand, guys. Look at your hand. Everyone look at their right hand right now, their palm, and tell me these are not dendritic ridges that are imprinted on our skin. I mean, this is the nature of the universe. This is the Birkeland current. Like, you have palmistry, this holistic look at. I mean, there's even the X that you find on the moon. You have the two bands of Jupiter. You have the two. This is